In this problem, we are asked to factor a polynomial with a degree of 3, which means there could be up to 3 factors when we're all said and done. They're nice enough here to tell us that one of those factors is x minus 2. So we can tell that g of x will factor into x minus 2 times some other stuff. Presumably there's going to be 2 more factors here for a grand total of 3 factors. To figure out what those other 2 factors are, let's take g of x and divide it by the factor that we already know. Whatever's left will give us the remaining 2 factors. Now you can do this with long division, or you can do it with synthetic. I'm going to choose to do synthetic because it's a little quicker, I think. I need to put positive 2 in the box because that's the value of x that would make what I'm dividing by equal 0. Then I'm going to line up the coefficients from the original problem, 1, 5, negative 2, and negative 24. I don't need to fill in any zeros because all the powers of x are accounted for. Then I do the synthetic division, bring down the 1, multiply by the box number gives me 2, add down the column gives you 7, multiply by the box number gives you 14, add down the column gives you 12, multiply by the box number gives you 24, and you should get a 0 as your remainder for all of these problems because what they're telling you is a factor, which means it should come out, when you divide, it should come out without a remainder. That's what makes it a factor. The way I interpret the remaining numbers is that this is 1x squared, because we always have an answer that is a degree 1 less than the original problem. So this is x squared plus 7x and plus 12. This is a degree of 2. It will factor by quote-unquote unfoiling it. X squared comes from x times x. 12 could come from a number of things. I believe that one that works out here is plus 3 and plus 4. I'll double check it. If I were to distribute this back out, I would get a 4x loop and I would get a 3x loop. These would combine to give me the 7x in the middle. That tells me my remaining 2 factors are x plus 3 and x plus 4, and this altogether would be the factored version of g of x.